In the 1960s, Britain was rushing to replace its bombed-out terraces and aging slums. The government needed to house hundreds of thousands of families quickly, and mass vertical housing seemed like the obvious answer. The solution to this urgent demand was a Danish design called the Larsen-Nielsen system. Instead of pouring concrete on site, factories produced massive precast concrete slabs that were simply craned into place, stacked on top of each other like a set of building blocks. For the people moving in, these modern towers offered an elevated escape from the crumbling streets below. They were promised a clean, comfortable, and rigorously tested environment. Which brings us to the morning of May 16, 1968. On the 18th floor of a brand new tower block called Ronan Point, a resident named Ivy Hodge walked into her kitchen, filled her kettle, and struck a single match to light her gas stove. That completely routine action, making a morning cup of tea, exposed a lethal oversight buried inside the era's most fashionable architectural solution. The stove in Ivy Hodge's kitchen had a faulty connection. Gas had pooled in the room overnight, and the moment the match was struck, it ignited in a sudden flash. The resulting blast produced a pressure of only 3 pounds per square inch, barely enough to crack a neighbor's interior plaster. Yet in the next few seconds, the entire southeast corner of the tower peeled away from top to bottom, crashing into the courtyard below. 4 people were killed and 17 more were injured, all of them having gone to sleep in a brand new home they implicitly trusted. The government immediately convened a public inquiry to find out who had ignored the building codes. They found that Ronan Point had not broken a single regulation. It had complied entirely with the law as it stood. The investigators were left with a deeply unsettling question. How could a perfectly legal, state-of-the-art structure be brought down by an explosion that exerted less force than a strong gust of wind? To answer that, you have to look at how Ronan Point was put together. Unlike traditional high-rises, this building had absolutely no interior steel skeleton to tie the floors into a continuous frame. Instead, the vast concrete slabs were essentially balanced on one another. The massive structure relied on almost nothing more than friction, gravity, and a small amount of mortar squeezed into the joints to stay upright. This diagram shows the vertical load path. The upper floor's weight transferred straight down through exterior walls. Without a secondary frame, if an explosion pushed out one load-bearing panel, the floor above fell, shattering everything beneath it, a rapid chain reaction engineers call progressive collapse. The original architects and code writers had planned for wind, fire, and the weight of the concrete itself, but a localized internal accident knocking out one single load-bearing panel was a scenario that fell through a gap in the industry's collective imagination. Following the immediate inquiry, temporary steel brackets called blast angles were bolted onto the surviving sections of the building, and then, incredibly, Ronan Point was left standing, with families living inside, for another 18 years. When a tower was finally condemned in 1986, structural engineer Sam Webb insisted it should not be blown up. He argued it needed to be dismantled slowly, piece by piece, so the hidden interior connections could be examined in the open air. When workers finally peeled back the concrete, they found a second disaster waiting inside. The mechanical connections that were supposed to hold the walls and floors together were wildly deficient. Bolts were entirely missing, and connecting nuts had never even been tightened. Missing structural mortar was replaced by construction site rubbish, cigarette packets, and old newspapers, hidden deep inside the supposedly solid concrete joints. Investigators concluded that by the late 1980s, the entire building was physically shifting on its lifting bolts. It was only being held up by the emergency steel brackets bolted on after the 1968 explosion. The official inquiry had identified a severe flaw in the blueprints, but the physical reality was far worse. The tower was destroyed by a dangerous theory made lethal by an abysmal failure of physical execution. When you layer the two investigations over one another, you see exactly what Ronan Point was, a fragile house of cards built by negligent hands. Ivy Hodge's match was never the true cause of the disaster. The building had been waiting for an excuse to fall since the day it opened. The gas explosion merely gave it permission. In exchange for the 4 lives lost, the British government introduced sweeping new regulations in 1970, known as the disproportionate collapse provisions. These rules soon permeated global engineering standards. This diagram shows the new requirement called alternate load paths. If an accident destroys a column, the weight must route horizontally around the damage to the ground. To achieve this, heavy steel ties run vertically and horizontally, knitting panels into a single connected body. Ronan Point changed the core objective of engineering. Designers moved away from assuming flawless construction and began building structures specifically to survive the inevitable failure of individual parts. Modern structural safety relies on redundancy. A building remains standing because it has the capacity to route its weight around a failing joint, proving that survival is found in a structure's ability to forgive.